So in week 5, we looked at moving from a local perspective in data science to a global perspective in data science. So the topic that we used was climate change. So scientists have concluded that our climate's changing and that global temperatures are on the rise, and this can have serious consequences. But in an age of plentiful information that we can describe from the internet, how do students separate fact from fiction? Which is simple. We examine the source data and we do the math. Underneath, I've included a link to climate change if you're not aware of some of the details. But overall, climate change refers to the broad range of global phenomena, predominantly by burning fossil fuels, which has added heat trapping gas to the Earth's atmosphere, okay, which increases the temperature global trends over time. But it also encompasses change in sea level rises and ice mass loss, okay, or in extreme weather events. So the question that I asked all of you is, climate change is driven by the increase in global temperature, but how do we know that global temperature is on the rise? And we talked about the answer. So what sources of information do we get? It might be from the news, it might be from our parents, it might be from our friends or family, okay? And what bias do those people have, okay? And how do we actually know that global temperatures are changing? We then looked at the global temperature data set of reported temperature anomalies. And the reported temperature anomalies are the measure of difference from a reference value or a long-term average, okay? So a positive anomaly indicates that the observed temperature was warmer than the reference value, and a negative anomaly indicates the observed temperature was cooler than the reference value. So anomalies are used because they more accurately describe the variability over a large range or a large time set than absolute temperatures do. So we looked at statistical correlation as our main idea for the day. So statistical correlation is about measuring the strength of a linear association between two numerical quantitative variables obtained from the same set of data. So one of the variables is called the independent variable, and you plot that on the x-axis, and the other is called the dependent variable, which is plotted on the y-axis. So the difference between the two is the independent variable is the explanatory variable, so it's explaining the dependent variable, which is acting in response to the independent variable. So there are different types of correlation. We have a negative correlation, where your values will decrease, okay, at a linear steady rate, and you have a positive correlation where your values will increase at a linear steady rate, okay? And when I say linear, it might be over time, it might be over weight or height. It just has to increase at a steady rate in the same, so we're heading towards almost a perfect line of variables, okay? And then we've got moderate and no correlation. So in moderate, the data points are spread out a little bit more, and in no correlation, the data points are just spread all over your data set. So we looked at our global data tasks, okay? So this is what I asked you to do for today. So we looked at a time series data set that showed monthly measurements of the average global land and ocean temperature over approximately 136 years, okay? So then in groups, you had to determine the short-term and long-term effects of global temperature over time using statistical analysis, okay? And then we downloaded this temperature data set, okay? And then I talked about understanding the data, okay? So your data is contained in two columns. The first column contains your date information. The first 4 digits represent the year, and the last 2 digits represented the month. So an example was 1880-01 is January, okay, 1880, or 01-1880, and then 02-1880, and so on and so forth. The second column is the global land and ocean temperature anomaly in degrees Celsius, compared with the average temperature, which was 13.9 degrees Celsius from 1901 to the year 2000. Okay, we then created an actual temperature data set. With the data in Open Spreadsheet, we created a third column and we labeled it actual temperature. Okay, you needed to create a formula and fill the third column with the actual temperature, and you can do that by adding 13.9 degrees to the corresponding anomaly for each month, and then you can click and drag down. Okay. I then asked you to graph that data set. Okay, and we're going to be doing that together. These are the instructions for how it might look if you use Tuba. So you can, of course, use Tuba if you want to use Tuba. Okay, but let's do that here.